Okay, so let's recap where we left off. So in the previous part, we created this class called DataNode that has the following attributes. One is the key that we will use to organize our data within the tree once we start inserting nodes into the tree, and or try to traverse the tree as well. The data over here is the basic payload that this node would carry. And then we have a left and right references of the same class, right, to point to either the left node or the right node children. Then we have a constructor right here that simply takes two parameters, it has two arguments here, key and the actual data, and assigns them to the attributes that are here, key and data. And then we have a toString method that simply prints the content of the, in terms of what is the key and what is your data that is within that node. For that, we had two methods, getData and getKey. Let's look at it here. So somewhere in here we have the getData and getKey. Here they are. So line 28, getKey simply returns the key. GetData simply returns the string type data. Next, we have, so we're looking at accessors. So this whole block here is for accessors. And we're looking at the getLeft. So this will return the actual reference to the left child. This will return the reference of the right child, basically the address of if you do have a child. If not, this will be null, right? So notice when we build a node, automatically left and right are null because we didn't assign any values to them. Eventually they'll have values, right? Once you've created an object and you've assigned it either to the left or the right. So for that, you need two methods, setLeft or setRight. You're going to give it a node, and you're going to make the left pointers, basically, equal to what you're providing it. So you basically now will hold an actual address that is not null. Okay? And same thing here, you will pick up an address of a node that means your right reference here will no longer be null. Okay, so for the next video, what we will do, so this is a transitional video between two parts. We will go ahead and create two files. So let me go ahead and start them, and then I'll pause here for the next video. So I'm going to go over here and create the actual binary tree class. So let's call it binary tree. We're going to need this one. And then we're going to need our application. So let's go over here, and we're going to go ahead and create our own application, and we're going to call it test binary tree. Now this one will have the main method here, and our application will be tested from here. So basically, we need to do the implementation of the binary tree based on the fact that we actually have full definition on how a node will behave and what it's supposed to be storing. So this will be our challenge for the next video on how to create this binary tree. And as we do that, we're going to be testing it here in terms of adding nodes to the binary tree, being able to traverse the node in using various techniques. For example, in order, post order, pre-order, and being able to remove a node from a tree. Okay, so I will see you for the next video.